We're going to start with ionic bonds. Ionic bonds are a give and take situation where one atom is going to give another atom its electrons. And because we are either losing or gaining electrons, one atom is going to become more, well, both atoms will become charged. One will become more negative because it's picking up a negative charged particle, and one will become more positive because it's giving up a negatively charged particle. And these are, so ionic bonds are going to be when one atom gives or transfers or donates an electron to another atom. The one atom that donates the electron is going to become a cation. Remember, a cation is a positively charged element, right? Because it's getting rid of this electrical charge, this negative charge. And the one that picks up or receives the electrons will become an anion because it's going to become more negatively charged. And because opposites attract, this attraction will hold the two elements together. And you can see that right here. So this one becomes a cation, this one becomes a anion. Now, the number of electrons that can transfer will kind of depend on how many electrons are in that outer shell. Remember, we want the electron to be stable, so we want the shell to be either full or empty, that outer shell. And so depending on how many electrons there are in the outer shell will kind of determine how many it can give. Now, ionic compounds have some very distinct properties to them. So first of all, ionic compounds are always going to occur between a metal and a non-metal. So one of the activities that you're going to be doing today or this week is that you'll be looking at a periodic table and predicting whether an ionic bond forms or a covalent bond forms. And all you need to do is look at the different elements that are involved and see, well, is one a metal and one a non-metal? And if so, then typically an ionic bond is going to form. Ionic bonds are stronger than covalent bonds, which we'll talk about next. Ionic solids are crystalline structures, so they form kind of like a crystal lattice, and so it makes them very rigid, and it also makes them very brittle. They typically have high melting and boiling points. The solids of ionic bonds in the solid state are typically really poor conductors of electricity, and that's because they're so embedded in this crystal structure that those electrons can't move very well. Now, however, if you dissolve ionic compounds into water, then because those electrons are all spread out, these can actually conduct electricity.